been introduced. My name is Ayelet Dahan. I'm an I don't need this right now. I can have this hanging there. It's just nice to have things in my hands. I'm an architect and Frontend Team Lead at Solidus Labs. And today we'll be talking about cartoons and how they inspire me. I trust that everybody here is a proper geek that knows who SheRa is. Nice, good, thank you. But after we get through the geeky stuff, we'll be talking about object-oriented programming in Angular and why that's even important. SheRa. This is the new version of SheRa. The original SheRa, I don't have pictures of her, aired in the mid-80s. She was the twin sister of He-Man. It's another cartoon that existed. No, SheRa is the thing, not He-Man. You need to root for SheRa. Produced by DreamWorks and Netflix. Created by one Noelle Stevenson. I really recommend following her. She's a really interesting personality. She's done quite an amazing thing. Put together an amazing team for the SheRa show. Quick review for those who don't know who SheRa is. It's in this version, it's a girl, teenager, come woman that discovers that she can wield some magical sword. And when she calls out, "By the power of Grayskull!" she grows about half a meter, maybe even a little more, and her dress changes completely, not like I can't change anything. And obviously she has some superpowers and can do magical things with a sword. But SheRa is just, if you think of the world that we live in, she's just the main page, the main component. It drives the whole story. It's important, but it's not the only thing. You can't drive a product without other assistance, without the other parts of your story, without your other components, without teamwork. And the Princesses of Power, which is the full name, SheRa and the Princesses of Power, they're our drivers inside our application. They create the teamwork inside the show. And what I loved about the show, and it's absolutely not related to anything about programming, is the teamwork that happens there and the way they build the characters. So just like any other normal cartoon, there's the protagonist and there's the enemies and there's the team that works together, and each part of the team has their strengths and weaknesses, and by working together they can achieve much greater things, and that's how we also want to build our applications. In our weird case, we can think of, there's a character called Katra. She's sometimes our frenemy. I think of the Backend sometimes as my frenemy. They give me the data I need to show in the application, but sometimes they surprise me in unexpected ways. So it's sort of a love-hate relationship that goes on there. Other interesting characters that are, again, not completely related to the talk. There is a character named Bo. He's a bisexual male. That's how he identifies, according to the internet. That's an important asterisk. There's a lesbian couple in there, two princesses that are married. Bo's parents are gay. And my favorite agent of chaos, if anyone bothers to see this is a tiny bit of a spoiler, is a character called Double Trouble. It changes shapes, and it's non-binary gay. That's the definition that the internet gave it, and it was confirmed by Noelle Stevenson, who created it. Enough about SheRa. This is very exciting to me. I love the show. I love how it's inspired, but let's get into object-oriented programming and how this is actually related to Angular. We'll go through some general foundations just to get everybody aligned. So even if you're a beginner to JavaScript, a beginner to Angular, we'll have that foundation worked out for you in general and in JavaScript. Then we'll come back home to Angular and we'll see a bit of a code example. Let's lay the foundations. Object-oriented programming. I'll start saying object-oriented because I'm sort of assuming that you all know what programming is, even though we might not agree on that. Object-oriented means that we're looking at our world of data through objects. We want to objectify, pardon my French here, we want to objectify our data. We want to make sure that we understand where things come from and sort of frame them very clearly. I'm going to try and explain that a little better. So well-defined will be our first requirement. When we are thinking about the data or the components that we want to build or the user experience or anything we want to go through, we want to take a moment, and just like we take a moment to name our variables, you do take a moment to name your variables, right? Good. I see a few notes, that's important. Take a moment to think about your architecture, about how you define your objects, your bits of data. And this is relevant for anything that you do. It can come from the smallest component to the whole project in itself. Second, jumped ahead, okay. Second, you want to control your data. Once you get it, you usually want to manipulate it. If it's static data, you could build a static site, and maybe it's not the best idea to bring in Angular. It's a bit of a heavy framework there. So we'll have some control methods, and those are the two key things. It's not everything about object-oriented, but those are the two key things that I'd like to sort of keep in mind while we're going through the process. So if we take the most trivial example, if you have an array in JavaScript, so the array is the class that we are using. It's an object. It is actually an object, in case you weren't aware of that. It has its data, so you store your data inside the array, and you control it through push and pop and shift and map, and you can do lots of things with it. So that's a very basic example. In case you recognize the cat from Scratch, this cat wants to play a game. It's a very dangerous game, so should be kind of careful. We're building a game. The cat has a sword. The sword should have some properties for various reasons. It can have length and weight, and you can decide if it's withdrawn or not. You want to store the state. And you want to have some control functions. You want to know if it's withdrawn or if it's sheathed. That's a hard word to say. And you use the is withdrawn property. The data that you have inside the class, you use it to control and to understand what you should do, because if you call withdraw twice and the sword is already withdrawn, you might want to make some different decisions about what's happening there. For example, you want to shake it again. If you want to let the evil cat attack some enemy, then you might use the weight and the length to calculate what damage this sword can do. Going to JavaScript specifically, we have objects in JavaScript. There's nothing, I hope, nothing very new to you there. Anything that's not one of the primitives, the strings, the numbers, the booleans, the null undefined, and a few other symbols, I think. Anything that's not that is an object. And when we have an object will have properties, so that's where we store our data, and prototypal inheritance. It's always a hard one for me. Made it through. Prototypal inheritance is a discussion for a completely separate talk, but in general, it's our way of accessing more and more information that we got from other sources of data that we inherit from. I'm not going to go into inheritance. In ES 2015, class keyword was added to JavaScript. MDN describes classes as templates for creating objects. They encapsulate data with code to work on that data. I don't find this very helpful, so I'll break it down a little bit. Template means we can reuse it. We're reusing objects all the time, so it's in itself a template. But when we create that class, we repeat our usage of it again and again with different data. That's the encapsulated data, the data that we choose to put in. And the code to work on the data are our control functions that we put on our class. Essentially, classes could have been created also before we had the class keyword. It's syntactic sugar that JavaScript added. It just standardizes how we do things, and we get two things out of the standard. One, we get the constructor function, where we won't just set the values of objects at the time they're created, but we can do some smarter, make some smarter decisions. And we have the prototype functions. Originally, if you just had an object, you created the object, and you had object.prototype, the name of the function, and then you would get those functions of the prototype. This just made everything cleaner, and you can just list the class, the properties, and its methods, and the constructor, and you have everything you need. Finally, you get testability. Did you notice that there's the word stability in testability? I really liked that when I found that out when I was writing this. So testability to me is one of the most important parts. It makes sure that your code is stable, that when you change it, you know that you've changed it and you need to make change to your tests. But if you don't change it, you know it's going to continue working, and if your test pass, most likely your code is still working. So it's always good to have tests on your classes. Coming home to Angular. We use object-oriented and classes in Angular all the time. We don't even necessarily notice it. When we create components, we have the class keyword, we're using it there. When we create services, we have the class keyword there. We're not even noticing it most of the time because most of us are using the CLI. We even have our constructor that we use for dependency injection. Again, we don't necessarily notice that we're using it because it's just for dependency injection half of the time. But we can do a lot of smarter things with that. So what do we do with everything that's not a component or a service? Most of the time, we just plug all our business data inside either the component or the service. And what I want to encourage is actually think a minute out of the boxes of the components and services and see maybe it's better to take it outside and put it in a class of its own, because you get separation of concerns, because the component should be handling the UI and the class should be handling its own brains, its own wisdom. You improve readability. Every time the code becomes too long, it's not very helpful. So it's much better if you have a short bit of code with very few functions. And of course, you get testability, because the component, you check only what the component does, and in the class, you'll be checking what the class does. So if we go back to the example of the array before, if you want to start storing state, yes, you can use NGRX and you can put in more complex tools, but maybe you just need to store the state of this array. You want to know that the user just changed it, and you want to know that somewhere in the list something changed, so you can highlight the save button and enable it. For that, I'm not sure if you need a whole NGRX state manager. You might just be able to use a class to maintain that. Enter the class. So let's look at a bit of a realistic example. I'm not sure how realistic, but let's have a look at it anyway. Did you know that you can put inside the template URL when you're declaring a component an SVG file and it'll run just fine? So, cool. Nice for whoever knew this. So that's the example that we're running now. We're going to draw some nice shapes. We have an SVG. And if we don't have any wisdom of our own, we're not going to show it. First rule, don't show anything, don't do anything, don't say anything if you don't have something to say. I've been talking quite a lot for now, so not sure I'm abiding by my own rule. Inside the SVG, one of the elements you can plug in is a polygon. We'll want a list of polygons, not just one. Come on, load. Try it again. Okay, there we go. Our wisdom that we check before that we actually have, so we don't get any exceptions here, has a list of shapes. I might explain later why one's called a polygon, one's called a shape, but bear with me for now. Each of our shapes has a list of points. That's how SVG likes to get their data. So each shape is going to put a list of points, and then we're going to get some nice polygons here. Very exciting. So our polygons have points, build of X and Y. We have a list of polygons. we have a shape, and this is why we had shapes and polygons separately, because we want to have a few more properties. We're not going into it during the talk, but you can later look at the slides and look at the actual source code, and you see why and how we're actually using the style. And finally, a list of shapes gives us wisdom. Well, at least gave me some. Little side step for interfaces. This is purely TypeScript. Interfaces don't compile out into JavaScript, but they're very helpful in telling us, while we're coding in our IDE, telling us our boundaries of our data. This is how we well define our data. Interfaces don't have to be only properties, they can be also functions, but in the case of data coming in from the backend, from a server, even from a JSON file, from the assets folder, we'll just have data structures, and this is a helpful way to describe it so you can keep everything in line and checked at compile time. Let's build our wisdom class. So our wisdom class will have a public property of shapes. That's the one we saw before for the ng4. And it has a constructor that gets this list of eye shapes, right? The interface that we defined before. And it's very helpful that we differentiate between shapes and eye shapes, because it's not always that the data that came in from the backend is exactly the data that you want to show or manage. A constructor is a great time and opportunity to make these changes. Very important point, always check your data. You cannot trust at runtime. I think there's another talk about not trusting your code. You cannot trust at runtime what the actual data you received is. It might be a null. It might be that this is a string and not an array. So it's always a really good idea to check it at runtime. Make sure that what you got is what you actually expected. In this case, I'm throwing an exception, which would have theoretically happened anyway. But this is a controlled scenario. You're explicitly saying that you're throwing an error, and when you're explicitly saying it, you can document it, and whoever is using your function, your class, your library will know that an exception might be thrown and can choose rightfully to wrap with a try-catch, that constructor. Second part is creating the shapes themselves. We have the list of shapes, and we are calling the shape constructor. Inside the shapes constructor, we're storing the points, and inside the points constructor, blah, 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 blah. We get the idea. Why do we need classes for such little items? And you have a point there, even though you might be trolling me. Or maybe it's just the voices in my head. The classes are here because they will serve a purpose later, and we'll get to that. If something is simple enough that there's no need for construction, that it doesn't have any value, you can keep it as a type or an interface. There's no need for the classes, but for the sake of our example, we're still going to have it. Quick recap, we have our wisdom class. It has its shapes, the list of shapes that it creates inside, and each of these shapes has multiple points. A reminder, we had our SVG with those polygons, and each polygon has those list of points. Every point creates at the end, they connect at the end and create a polygon. So if we would write this manually, it would be points x1, comma, y1, space, x2, blah, 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 blah. But we're not writing it manually, so we want to consider these pairs, which are the points we're looking at. And between each of these pairs, we'll have a space. This is why we had the class. That's why the troll face is back there. Our point will expose a function that gives us the pair, that creates the correct structure. If we wanted to have all this in one class, sorry, I gotta smile to the camera. You're not taking pictures, man. Clicker. Good, done. If we didn't have this, we'd have to plug this all inside the shape, all inside the wisdom, and we wouldn't be getting very far with that. Everything would just be bundled in one place, and that would be kind of sad. Then we have the points, right? We had the shape that has a list of points. So now we can go over each of these points through a map, get those pairs, right? They were comma separated, and then join them with spaces. So in fact, shape point is creating exactly what we needed. Demo type. But if I can go back for a second, the beauty of this is that it keeps everything very clean. Only display issues are in the component, and everything else is in separated classes, which you can test independently. Let's see how this goes. Yeah. That's the shape we've been drawing. That's a lovely wisdom. I'm sure you believe me, but you can see this is actually an Angular component. I'll even show you on the network. But I'm loading it and it's real. This is what the JSON, the actual JSON looked like. You have here the polygons with all the points. And if we look at the actual elements that we drew, we have here all beautiful polygons. It's the A character. And you can see on the right-hand side, I left the styles available. You can see how they're getting their colors. There's a class applied right here. Oops, no. There's a class applied right here. And those classes were defined just like you would define any other class in Angular. And all the styles are right in here. So there's nothing special about building this SVG. I can even compare. This is how the original Angular SVG that I pulled off Angular website for the press kit, this is how they built it. So there are 2 polygons, one for each, one for each side. And there's a path for the A, so that's a little different from how I built it. And there's a little bit of magic that happens here if you download the actual example by clicking anywhere. I do magic and I change into the Angular material shield. And it's built in exactly the same way. You can see the beautiful layers. I love this. This is very nice. Okay, that was our demo. Just to summarize things up. Components, preferably, if it's starting to get complicated, should handle the inputs, the outputs, the other components, and everything else should hand off to the classes. The components handle the display, they handle the user interactions. It's got enough brains of its own. If there's any business data, if there's any wisdom that you need to handle, hand it off to classes. Your classes should have the properties with a well-defined data. Your classes should have functions to manage the data. Your classes should be independent of each other. You want to keep these separations as much as you want. Obviously, don't overdo it because then there'll be too much code in the system and hard to maintain. And finally, it's testable. Test, 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 test. That's it. You can find the source codes at Ayelet Dahan, SheRa ng-up. You can reach out to me on Twitter, LinkedIn. I work at Solidus Labs, and if you like SheRa Show, follow Noel Stevenson. Thank you very much. I hope you had a good sleep.